Hello everyone. In today's session, we are going to learn about how to find out the prime implicants and prime implicates along with essential prime implicants and essential prime implicates. We will first understand what are implicants and we will understand what are prime implicants and how to identify essential prime implicants. Let us start with the implicant. Implicant is every single one cell which gives a product term. It is termed as an implicant. That means in a K-map, every logic one cell in the K-map is termed as a implicant. Let us go for prime implicant. The prime implicants are product terms obtained by all possible grouping in the K. The essential prime implicants are a prime implicant on a Karnaugh map, which covers at least one logic one which is not covered by any other prime implicant. Now let us identify the implicants, prime implicants and essential prime implicants considering an example. Let us consider an example given here. F of ABCD equal to summation m 3, 4, 5, 7, 9, 13, 14, 15, and let us obtain the prime implicants and essential prime implicants for the given Boolean function. So the total number of variables are 4, therefore we will plot a 4 variable K-map. As the given expression is summation m, that is SOP form, min-term canonical form, we need to place logic ones for the respective decimal numbers in the K-map. So let us plot the K-map. We need to place logic 1 in cell number 3, 4, 5, 7, 9, 13, 14 and 15. In the remaining cells, we need to place logic zeros. Now we need to start grouping logic ones in order to obtain the prime implicants and essential prime implicants. Now we can start grouping considering the highest priority grouping, that is forming an octet. We can see from the plot that we cannot form an octet, therefore we can go for the next priority grouping, that is quad. So let us form a quad which is visible clearly here in the K-map. So this forms a K-map. Let us name this as group number 1. Next, we have 4 more logic ones left out in the K-map. So to cover these logic ones, we can form a pair here. We can form a pair here. And to cover this logic one, we can form a pair, one more pair here. So let's give the numbers for each of the grouping. So this is group number 2. This is group number 3. This is group number 4. And this is group number 5. Each logic one in the K-map will be a implicant. Now, all possible grouping gives you the prime implicants. Let us write the product term for each of the group. Considering quad, that is group number 1, we get a prime implicant BD. So let's consider the rows and columns of that particular group in order to obtain a prime implicant. So we obtain BD, the prime implicant as BD. Considering group number 2, so considering group number 2 as shown here, and this pair is occupied by these 2 rows and this column, therefore we have A bar and CD. A bar, CD. So let us write the prime implicant here. It is A bar, CD. Considering the next grouping, this pair, that is group number 3, we have a prime implicant, that is product term, A bar B. Considering the columns, we get it as C bar. So therefore, it is the prime implicant will be A bar B C bar. Considering group number 4, we get a product term, that is nothing but a prime implicant A C bar D. Considering the group number 5, we get a product term, that is prime implicant A B C. Now let us find out whether these prime implicants are essential prime implicants or not. Now considering a the first grouping, we need to check the logic ones which is covered by only one group. So we have 4 logic ones which is covered by more than one group. Therefore, we cannot consider the first prime implicant as an essential prime implicant. Now, if we observe all these pairs, that is the remaining 4 pairs we have formed here, we can see that each logic one in these pairs is covered by only one group. Therefore, the remaining groups, that is remaining prime implicants, can be considered as an essential prime implicants. So, we have A bar CD as an essential prime implicant, A bar B C bar, A C bar D, and ABC. All these are essential prime implicants.
The next example is an SOP expression for which you need to obtain the prime implicants and essential prime implicants. Now let us plot the K-map for each of the product term considered in SOP expression. So the first product term A bar C bar D, considering the rows and columns in the K-map, we can place logic 1 in cell number 1 and 5. Next, considering the next product term A bar C D, we can place logic 1 in cell number 3 and 7. Considering the next product term B bar C bar D bar, we can place logic 1 in cell number 0 and cell number 8. Considering A, B bar, C, we can place logic 1 in cell number 10 and cell number 11. And the last product term is A bar, B bar, C, D bar. We can place a logic 1 in cell number 2. In the remaining cells, we need to place logic zeros. Now, every single one cell in the K-map is termed as an implicant, which gives rise to a product term termed as an implicant. Now, let us find out the prime implicants by grouping logic ones in the K-map. Let's start grouping. All possible groupings in the K-map gives rise to a prime implicant. So the obvious grouping from the K-map will be acquired here because octet is not possible. So by considering all the 4 corner cells, we can form one more quad, and by folding the K-map, we can form one more quad, and we have 2 logic ones which are left out in the K-map, which can be again formed as one of the quad. So let me number this grouping. So this is group number 1. The corner cells will be considered as group number 2, and the quad here is group number 3, and we have one more quad formed by folding, so that is group number 4. So totally we have 4 prime implicants. Let us write the prime implicants one by one. Considering group number 1, we have prime implicant A bar, B bar. Considering the corner cells, we have prime implicant B bar, D bar. Considering group number 3, we have prime implicant A bar, D. Considering group number 4, we have prime implicant B bar, C. So these are the prime implicants for the given function. Now let us find out whether these are essential prime implicants or not. Now considering the first group which gives rise to a prime implicant A bar, B bar, we do not have a single logic 1 here in this group which is covered by only one group. Therefore, this is not considered as an essential prime implicant. Now let us consider group number 2, the corner cells, in which you have a logic 1 which is covered by only one cell, one group. Therefore, this will be considered as an essential prime implicant. The third group uh, is having 2 logic ones which is covered by a single group. Therefore, the third grouping is also considered as an essential prime implicant. Then group number 4, that is the folded, the K-map folding. After K-map folding, we have formed a quad here. So this quad has a logic 1 which is covered by only one group. Therefore, even this prime implicant is considered to be as an essential prime implicant.
Now let us obtain the prime implicants and essential prime implicants for the given max term canonical form. So let us plot the K-map. It is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. So we have to place logic zeros as the given expression is max term. So let's place logic zeros for cell numbers 0, 2, 3, 4, 6, 7, 11, and we have one more term, that is don't care term, to the cell number 12. In the remaining cells we need to place logic 1. Now let us start grouping logic 1. We do not find 8 adjacent logic 1 cell, therefore we need to go for the next priority grouping, that is quad. So we can easily find out a quad which can be formed here. By folding the K map with the help of the don't care, you can form one more quad here, and it is also possible to form a quad here to cover the logic 1 at the cell number 15. Remember that prime implicants are, in order to find out the prime implicant, you need to form all possible groupings including the don't care terms in order to cover the logic 1. So considering this concept, you can also form the other grouping which is formed here. So totally we can have 4 quads. So let us write the prime implicants for each of this. Let's number each of the grouping. So this is 1, this is 2, third one is this, and the fourth one is this. So let's write the product term, that is prime implicants for each of this, and identify whether it is a essential prime implicant or not. Look into the first grouping, the first quad. So we obtain the prime implicant as C bar D. The second one, the second grouping is the horizontal quad, where you can obtain the prime implicant as AB. And the third grouping is A. Considering the columns, we get D bar. And the fourth quad, we get A, and considering the columns, it is C bar. So we have the prime implicants C bar D, AB, AD bar, AC bar are the prime implicants. Let us now find out whether these are essential prime implicants or not. Let's start with the first quad here. So this quad has two logic ones which is covered by only one group. Therefore, we can consider this as an essential prime implicant. So let's write this under essential prime implicant. The second grouping. The second grouping is this. So when we consider the logic ones in this group, we find one logic one which is covered by only one group. Therefore, we can consider the second prime implicant AB also as an essential prime implicant. The next is third grouping. Considering the third grouping, we have actually three logic ones here. We should not consider the don't care while finding the essential prime implicant. So we have three logic ones. Considering these three logic ones, we have a logic one which is covered only by one group. Therefore, we can consider AD bar also as an essential prime implicant. The last grouping is this. In this quad, we have three logic ones which are covered more than one time, more than one group. Therefore, this is not considered as an essential prime implicant. So these are the prime implicants and essential prime implicants for the given max term canonical form. The next we will see what are prime implicates and essential prime implicates. Let us look into what is a implicate. Every single logic 0 cell gives a sum term which is termed as a implicate. So every logic 0 cell will be called as an implicate. The second one is prime implicate. The prime implicates are obtained by all possible groupings of logic 0 cells, which gives rise to a sum term. The next one is essential prime implicate. So a prime implicate on a Karnaugh map which covers at least one logic 0 which is not covered by any other prime implicate are termed as essential prime implicates.